Hello and welcome back. This is a section over 2.3 and 2.4. You're getting two sections for one video, huh? Pretty sweet. Okay, so we're going to be talking about linear functions, specifically slopes, graphs, and models. Okay, so a linear function. So this is a function that represents a line. And the reason why I know that is because my root word in linear is line. Okay, so the graphs, this will represent lines. All right? Okay, let's go ahead and let's talk about a few things. We've got equations in many different forms, okay? We've got equations in standard form where x and y are on the same side of the equal sign, x goes first. And then we have slope-intercept form, which is one of my favorites, okay? This is in the form of y equals mx plus b, where m is the slope and b is the y-intercept. Okay, so what is slope? Okay, slope is a measure of steepness, okay? Now, since we're all out here in Colorado, that's how we measure blue runs, green runs, and black runs when you're on the slopes. As I like to call it, when you're shredding the gnar, okay? So slope is a measure of steepness, all right? So we can actually quantify that. We also call this the rate of change, okay? So I'll kind of be using that as well. We use this formula to calculate slope, and I'll kind of show you guys how I do that. It's going to be more centered on what I have in my homework solutions, okay? And so we have different types of slope, okay? And this is important that we write this part down. That I know a positive slope goes up to the right, okay? Negative slope goes down to the left. Zero slope is horizontal, and if you have a vertical line, that's undefined slope, okay? So, so let's go ahead and take a look at an example, okay? What I want to do is I want to graph this function using the y-intercept and slope. So what I know is that this is already in slope-intercept form, okay? It takes the form of y equals mx plus b. So typically if you see something where it's like y equals something else, or f of x equals something else, and x is raised to the first power, then you have a linear function. And if it's in this form, then we can identify the slope and y-intercept. So let's go ahead and do that real quick. My slope m, in this case, m, is going to be negative 1/3, okay? And my y-intercept b, okay, that's what b is going to be 2. So my b value is equal to 2. Now this translates to the point on the graph of 0, 2. All right, and this is my starting point. Okay, this is always where I start. All right, so my y-intercept is 2. All right, so what I'm going to do is I'm going to label my axes over here with x and with y. Okay, and I'm going to go up 2, and I'm just going to go ahead and plot a point. All right, and I'm going to do that in blue. Okay, keep things straight. All right, now what I have is I have the slope of negative 1/3. Now let me go over here and write this over here. I'm going to write m is equal to negative 1/3. Now, when we often talk about slope, it's the change in y divided by the change in x. Okay, oftentimes you see the phrase rise over run. Okay, and so this tells you how to go. Okay, if I'm going to go, and so my first number, the number on top, my rise is negative 1. So what I'm going to do, that means I'm going to go down 1, okay, and then I'm going to run 3, okay? And so I'm going to go over 3, and then what I'm going to do is I'm going to plot a new point on the graph, okay? Now I can repeat that same process. I can go down 1 to the right 3 and plot another point, okay? And I can do that again, down 1 over 3, and plot a point, all right? And you get this stair-step model, all right? I can also do the same thing. I can go up 1 and to the left 3, okay, and plot a point, all right? And so if I connect all of these points with a line, because that's what they're going to make, and let me kind of just do a few more of these, up 1 over 3, up 1 over 3, I get these other points on here, all right? So if I connect them, this is my line, okay? And this represents the function f of x is equal to negative 1/3 x plus 2, all right? And that's the idea. That's all we're doing. Okay, so it's important that we identify and know how to find the slope. Now what I'm going to do real quick, I'm just going to pick a couple of these points to make sure that we have the right slope of negative 1/3 and how we get that. Okay, this is going to be the point, this point right here is a point 3, 1. Okay, and then I'm just going to go ahead and you can use any 2 points on the graph. All right, let me use this as purple. Okay, this is the point 3, 1. And this is going to be the point 9, negative 1. Okay, now what I do is I want to figure out the slope between these 2 points. Now I'm going to use the formula m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, and I'm going to go ahead and label this point over here as my first x and y point. So I'm going to call that x sub 1 and y sub 1. Okay, it's because it's my first point. That's why I use the 1. Now over here, I'm going to call this x sub 2, y sub 2. Okay, and using the 2 to talk about my second point. So to plug these values in to find the slope, okay, I'm going to do y sub 2, which is negative 1. All right, and that's going to give me negative 1 minus 1. All right, just plug them in how you see. X sub 2 is going to be 9 minus 3. Okay, so x sub 2, x sub 1, so 9 minus 3. And that's going to give me a value of negative 1 minus 1 is negative 2. 9 minus 3 is going to give me 6. Now each of these are divisible by 2. So I can simplify this to negative 1/3, which is the slope that we had. Okay, so that's how you get the slope of a line given 2 points. All right, and how to graph, okay? All right, let's go ahead over here and let's talk about something else. Talk about point-slope form, okay? And so what we want to do is we have this form here, okay, where we have y minus y sub 1 is equal to m times x minus x sub 1, where n is the slope, and this point, xy, is a point on the line. So what we want to do is we want to find a linear function in function notation, so we're going to use f of x, whose graph has the given slope and y-intercept. All right, so let's just go ahead and graph this real quick. My slope, let's talk about my y-intercept first here at negative 2. Okay, so I can go down here, I'm going to plot this value at negative 2, okay, and then I have a slope of negative 2/3. So remember our slopes go positive, negative, 0, and undefined. All right, so because we have a negative slope, it's going to go in this direction. All right, so I'm going to go down 2 over 3. So I'm going to go down 2 over 3, plot a point. And I'm going to go up 2 and then over 3 and plot another point. Now I just need to plot a few points. I don't need to plot a bunch because I just need 2 points to draw a line. Okay, and that's all we need. All right, so there we got that. We're good on that front. All right, so now, I've graphed this equation. All right, now I'm going to do this 2 ways. Okay, I'm going to use point-slope form first. Okay, and I'm going to call my slope m is equal to negative 2/3, and my point on the graph is the point 0, negative 2. Okay, so I'm going to call this x sub 1, y sub 1. All right, now what I want to do is use my formula. Y minus y sub 1 is equal to m times x minus x sub 1. All right, and I'm going to go ahead and plug these values in. So I'm going to write y minus, and y sub 1 is the value negative 2. Now I'm just going to go ahead and plug in negative 2 into that. All right, so make sure you keep your signs straight. All right, my slope m is negative 2/3, so I'm going to write negative 2/3. And then parentheses x minus x sub 1, which is 0. Okay, so that's that point there. All right, so now we can simplify and solve this for y. All right, now if I've got y minus negative 2, subtracting a negative really means that you're adding. So I'm going to do y plus 2. Okay, and then normally I would distribute my negative 2/3 into each of these values. But because I have x minus 0, that value is just going to be 0. So I just got negative 2/3 times x. Okay, and then I'm just going to go ahead and subtract 2 from both sides. All right, so I get y is equal to negative 2/3 x minus 2. All right, now this is in just as an equation. What I want to do is write this in function notation. So to write this in function notation, I would write f of x is equal to negative 2/3 x minus 2. and that's it. Now, I also want you to notice something, okay? We were given the slope and we were given the y-intercept. So if we're just thinking in terms of like y equals mx plus b, all right, if you already know your slope and you know that this is a y-intercept because that's what the point is, and that's what they tell you, okay, then just go ahead and just fill it in and write it, all right? Just write y equals negative 2/3 x minus 2, and that's it. Okay, write it in function notation, so do f of x is equal to negative 2/3 x minus 2, but that's all you need to do, okay? Now, if they didn't give you the y-intercept, this will still work, okay? And I'll also show you guys another way for me to write this equation if it's not, not using point slope form. Okay, so we've got a couple special forms here. Now, remember how I told you about slopes, where it was you either have a positive slope, you have a negative slope, you have a zero slope, or an undefined slope. Okay, so we're going to talk about these two types of lines here. All right, so we're talking about a line with a slope of 0. It yields a horizontal line. So that's this line here. Okay, the equation for this is y is equal to some number. So I'm going to put that this is like y is equal to b. Okay, now if we're undefined, okay, the vertical line that passes parallel to the y-axis, the equation is x equals some number. Okay, so we're going to do x equals some number a. All right, so this is pretty easy. A lot of times it's a little tricky, but it's really not too bad. So if I wanted to first graph this one, y equals negative 2, well, what I do, y equals negative 2, I know that's going to be a slope of 0. All right, and I'm going to go ahead and label my x-axis and my y-axis. Now what I do, if this is my equation, I'm just going to go down to negative 2, plot a point, and then I'm just going to draw a horizontal line. Okay, and the reason why I know that, the way I remember that, y is equal to negative 2. It's going to intersect the y-axis at that point. Okay, and we just draw that. Okay, and we can label it to y equals negative 2. We can do that. That's fun. We're having fun though, right? We're always having fun. Okay, let's go ahead and graph the line x equals 5. All right. And so let's go ahead and label this x, label that y, because x is equal to 5. I go to 5 on the y-axis, or I'm sorry, on the x-axis. And I've got 1, 2, 3, 4, 5. Okay, I'm going to plot a point there. And then because it's x equals, I'm just going to draw a vertical line. And that's that line that goes straight up and down. Okay, and we can label it, because we're having fun, x is equal to 5. Okay, so that's that. All right, quite a bit of stuff. Hopefully it's kind of a review for you. All right, see you in the next slide. Okay, so lastly, we want to talk about a couple of important points that are on any graph, and you can do this on a linear graph specifically, and it works kind of nice depending on what you're given. And so what we want to do for the x-intercept, okay, there are points that lie on the x-axis. Okay, so let's go ahead and over here, let's label x and label this axis y. All right, and so what I know is that to find the x-intercept, we let the y value equal 0 and solve for x. Okay, to find the y-intercept, we let x equal 0 and solve for y. Okay, and I'll show you why we do that here in a second. Okay, so but what I want to do for this example is I have the linear equation 3x plus 4y is equal to 12. Okay, now I'm going to do this, finding the x-intercept, finding the y-intercept, and then I'll find the slope, and then I'll graph it, and then I'll use that slope to find another point on the line. So we'll do all of these things for this one problem, okay? So let's do this, all right? Let's go ahead and find my x-intercept. Okay, so x-intercept, okay, means I'm going to let y equal 0 and solve for x. Okay, and I typically write this part down just so I know what I'm doing. Okay, it kind of took me a while to remember this. I remember when I was taking a class like this. So, if you got to write it down every single time to write down like a prompt for you to do, then do it. Okay, so let's do that. If I've got the equation 3x plus 4y, so let's let y equal 0. So 3x plus 4 times 0. All right, and that's equal to 12. All right. So what I know is that if I take 4 times 0, that's just going to give me 0. So as a result, we get 3x plus 0, and that's equal to 12. Now, if I take 0 and add it to 3x, nothing happens. I'm just going to get 3x. So I get 3x out of this, and that's equal to 12. If I divide by 3 on both sides, I'm going to get that x is equal to 4. Now this is my x-intercept. Now my value of x is equal to 4. My value of y in this case was equal to 0. Okay, and I chose this value to get this. So that's what you have to do. You have to plug in 0 for y to get your x-intercept. So now this translates to the point 4, 0. All right. Okay, let's do the y-intercept. All right, and y-intercept is just the opposite. So y-intercept means I'm going to let x equal 0 and solve for y. Okay, so I'm going to rewrite the same thing. So 3 times x, I'm going to plug in 0 for x, plus 4y is equal to 12. Now 3 times 0 is just going to give me 0. So I've got 0 plus 4y is equal to 12. 0 plus 4y is just going to give me 4y, and that's going to equal 12. Now if I divide by 4, then I'm going to get that y is equal to 3. Now y is equal to 3 when x was equal to 0. So this gives me the point 0, 3. All right, so I have these two x, here's my x-intercept, here's my y-intercept. All right, now let's go ahead and find the slope of the line. Now what I'm about to do, you're probably going to go, why didn't you just do that in the first place? This will come up again and again, okay? The ability to find your x and y intercepts is something that we'll be doing later, so I wanted to introduce it now for an easy function because these will get a little bit more difficult. All right, so part C, we want to find the slope of the line. Let me label this as A, B, K, and C. All right, so I had the equation. What I want to do is take that equation, and you know what? We could do this a number of ways. Okay, I'm going to do 3x plus 4y is equal to 12. Now what I'm going to do is I'm going to solve this equation for y. I'm going to move everything else over except for y. So that means I'm going to subtract 3x from both sides. Okay, and then we're going to get 4y is equal to negative 3x and then plus 12. Now I'm going to divide everything by 4, 4 and 4. All right, so then we get the equation y is equal to negative 3/4 x plus 3. Okay, 12 divided by 4 is 3. I can't simplify negative 3 over 4. Now, guys, this is of the form y equals mx plus b. So my slope, okay, the number in front of the x, is negative 3/4. So my slope m is equal to negative 3/4. I also know my y-intercept. My y-intercept is 3. So b is equal to 3. So what I can do, and let's just talk about a few things here, okay? I found my y-intercept already, okay, by plugging in 0 for x, and I have my x-intercept. Now I'm going to go ahead and plot those points. So I've got a y-intercept of 3, it's that point here, and then an x-intercept of 4, 0. Okay, now between those 2 points, I could also calculate the slope on the graph and draw my stair step. And I know that I go down 3 and over 4. Okay, now I could continue that process, go down 3 over 4 and plot a point. Okay, and this would be the point, just so we have it, this would be the point 8, negative 3. Okay, this is the point 4, 0. This is the point 0, 3. All right, so what I can do from here is connect these with a line. And I'm graphing my line. All right, now all we really needed were my y-intercept and my x-intercept. As long as we get those 2 points, I can plot those, draw my line, we're good. Don't need to do anything else. But it wanted us to find another point on this graph. Okay, so use the slope to find another point on the line. All right. Now another thing that I could do, okay, just to reiterate, and so you guys understand this, I could call this my first x value and my second x, my first y value, sorry. I could call this my second x value and my second y value. So what I could do is this. To find my slope, use my formula, y sub 2 minus y sub 1, so 3 minus 0, divided by x sub 2 minus x sub 1, so 0 minus 4. Now 3 minus 0 is just 3, 0 minus 4 is negative 4. So I could do it algebraically. So guys, what I'm trying to show you is that there's a number of ways to do this. Okay, get these points, you can use those points to calculate the slope. You can change this, solve this equation for y to put it in slope-intercept form to get the slope, or you could do it graphically, it doesn't matter. All right, I don't care, as long as we get it right, doesn't matter to me. All right, next one. Last one for this chapter. What I want to do is to determine whether an equation is linear. Okay, and if so, let's find the slope. So the first things first, okay, the only way that this works is that if I have something x to the first is in the equation, okay, if this is in my equation, all right, then it's linear. Then it's linear. All right. Now, if I go over here to part A, now part A is a little weird because it's in function notation, but they've got 3x plus 5 times f of x plus 15 is equal to 0. This is actually a linear function. What I want to do is solve for f of x. Now, remember, f of x is another way for me to say y. Okay, that's my y value. So let's rewrite this as 3x plus 5 times y plus 15. Now what I want, and this is all equal to 0. Now what I want to do is I want to move everything over except for the y. So I'm going to subtract 15. I'm going to subtract 3x from both sides. Okay, and move that over. So minus 3x minus 15. So as a result, we get this. We get 5y is equal to negative 3x minus 15. Now if I divide both sides by 5 and by 5 and by 5, I end up getting that y is equal to negative 3/5 x minus 3. Now what I'm looking for is that I have y is equal to some number with an x in it, and x is raised to the first power. That means that this is linear. Okay? Now if I want to find my slope m, then I'm just going to look at this, and it's going to give me negative 3/5, and that's it. Okay, so that's what we're doing. All right? Now let's take a look. Over here on part B. Now let's do part B. I'm going to write that down here. B, that's, what is that? Y equals 1/2 times x minus 4. So 1/2 times x minus 4 is equal to y. All right? Now, because the y is on the right side, that's totally okay. I can switch these around. All right? But before I do that, let's distribute this 1/2. So if I've got 1/2 times x minus 1/2 times 4, I'm going to put that over 1, that's going to be equal to y. All right, now once I do this, what I can do is I get 1/2 x, 1/2 times x, and then minus 1/2 times 4. Now to multiply fractions, I'm going to do 4 times 1, which gives me 4, and then 2 times 1, which gives me 2, and that's equal to y. So I get 1/2 x minus 2 is equal to y. Now this is linear because I have a degree of 1. My exponent above my x is just 1. I have a single x. So I'm going to call this that, yes, this is linear. And then my slope, m, is the number that's being multiplied in front of the x, which is 1/2. All right, and that's how I'm identifying that. Now we could rewrite this. We could rewrite this and change the order and say that this is y equals 1/2 x minus 2. We can do that. Okay, these mean the same thing. All right, so don't be afraid to kind of play with your equations there. All right. Now on this one, part C, well, let's go ahead and look at part D first. This has something x squared, okay? This is not linear. That's what we call a parabola. We'll talk all about those later on, but not today. So this is not linear, okay? I want to talk about C. C is where it gets kind of weird, okay? So C means that you have the equation y times x minus 4 is equal to 1/2. Okay? Now what I want to do, and this is where it gets weird, I want to solve this equation for y. Now I'm multiplying y by this quantity here, all right, x minus 4. And this is kind of the hard part about algebra, is bridging the gap of understanding how to solve this for y. Because I'm multiplying by a quantity, if I want to move that entire quantity over, I would then divide by x minus 4, that entire quantity. I'm going to do the same thing. I'm going to divide this over here by x minus 4. Now x minus 4 divided by x minus 4 divides out to 1. So you're left with this. You're left with y is equal to 1/2 divided by x minus 4. Now this is not linear. And the reason why is because x is in a denominator. So linear, not linear. And the reason is because x is in the denominator. All right? Now, we'll talk more about why that's the case, but this is not a linear function. What we'll do in class is we'll actually graph these and make sure that what we get is a line. Okay, so here's your homework for these two sections. I know it's a lot, I know it's terrible, but guys, if there's one thing we want you to be able to do when you take a college math course, is understand what a linear equation is and what slope is. All right, so hopefully it's familiar to you and you've seen it before. But what we'll do, get started on that homework. We'll reconvene in class. We'll see you in a bit. Thanks. Bye.